So thank you everyone for coming. So we are very glad that Tejal has joined us today. So Tejal did a master's at UMass Amherst, and then she was at IIT Bombay, and then she worked at TIS for a while, and then she's been at NIAS for the past several years. And Tejal has worked on many different aspects of climate change and equitable transitions and so on. And I found it really interesting just talking to her because I feel that some of her work is a pretty interesting window into how questions that we usually think of as questions which are outside the ambit of science about geopolitics and power relations and hegemony, in fact, have a bearing on questions that are scientific. And a couple of months ago, I think I was talking to her about understanding how some of these dynamics and the negotiations of climate change and so on happen, and I found it really interesting. And so I thought it would be really great for her to come and give us the same lesson that she gave me some time back. And so we are very glad to have Tejal here. So Tejal, go on.
I am going to talk about, so as we speak, there is actually an ongoing session on climate change under the UNFCCC, the United Nations Framework Convention on Climate Change, that is happening in Bonn, Germany. So Bonn is the headquarters of the UNFCCC, the convention, the UN convention that deals with climate change. And between two COPs, everybody knows that something about climate change is happening under the United Nations when a COP is happening, right? A conference of parties, typically in November or December, because you have a lot of media coverage during that time. Heads of state converge. So the last one was in Dubai. So there's a lot of discussion around that. But between two COPs, the work of the UNFCCC goes on for the entire year. It doesn't just happen from December to December. And between the two COPs, you have what is called an intersession, where the technical groups of the UNFCCC meet to discuss and have technical negotiations. So that's going on right now. It's just started yesterday, in fact. And it'll go on for 2 weeks. So like a COP, it's also a 2-week session. And it's very interesting that some of these issues are actually being discussed and negotiated on. Some of these issues which are thought of also as under the ambit of science, right? Modeling climate change for the future, modeling climate impacts for the future, and what are the drivers of climate change and how they are going to change for the future. So any form of mathematical modeling is thought of as an academic exercise, as something that happens in research institutes. Be it convection equations, you're doing Earth system modeling, or even if you're doing energy modeling, it's still within the ambit of what happens in academic institutions. However, a lot of this now has entered policy discussions. There are governments that negotiate about this, not ministers. When it goes to the level of the ministers, the negotiations are much more political. But one step below that, the bureaucracy is very much engaged in terms of what's happening with climate models and so on and so forth, even in India, even in developing countries. It's not just the bureaucracies of the developed world. So let me, so that's broadly where I'm coming from for this talk. What I will talk about is the context. We've all heard of net zero targets. India has a net zero emissions target for 2070. There is, in fact, just post-COVID, the COP 2020, which was supposed to happen in Glasgow, did not happen because of COVID. It was delayed by a year, 2021. It was an important COP because that is the year in which the Paris Agreement, which is the agreement currently which governs climate action, was supposed to come into effect. Right? So the COP was delayed by a year. That allowed the United States to come back into the Paris Agreement. So if you remember, the Paris Agreement was signed in Paris in 2015. It was, then it comes back. In Paris, governments basically sign it, but then it comes back and parliaments have to ratify it. Right? So the process of ratification takes a longer time. This is true of any international treaty. So the US went back home, they did ratify it, but then Trump won the elections and they decided not to participate in the Paris Agreement. So they began the process of withdrawing from the Paris Agreement. But of course, Trump lost the next time over, and this was just before the Paris Agreement actually came into effect. So Biden came back and said, we are back into the Paris Agreement, we are not getting out of it. Now, of course, this year, the US goes to elections again, and looks like Donald Trump might come back to power, then what happens, of course, is up in the air. It's not very clear. But around Glasgow, around that time is when you had this entire push for declaring net zero targets. Right? When is it that your country is going to reach net zero carbon emissions? And of course, there's some science around it, and there's a lot more politics around that particular target, but I'll talk about it briefly. So I'll set the context there. I will talk about some of the current frameworks that are modeling and projecting climate futures for society, what is the world going to look like in 2050, and what does the world need to look like if we are to live within 1.5 degrees or 2 degrees Celsius. The problem with current frameworks, and of course there are some other frameworks that are possible. So this is a fairly popular for those who work on climate studies. This was a very popular figure from the 5th assessment report of the IPCC, which was reproduced, improved and reproduced in the 6th assessment report. Everybody is aware of what the IPCC is, the Intergovernmental Panel on Climate Change. It's an intergovernmental panel, but it's a panel of scientists in some sense. They produce scientific reports, technical reports. There are 3 working groups. Working group 1 is on the physical science. Working group 2 is on the impacts and adaptation. Working group 3 is on mitigation. Right? So there are various aspects of it. They produce huge reports, but it's an intergovernmental panel. It's funded by the governments, and they produce a summary for policymakers. So those reports are sent back to governments to review. Right? But finally, the product is still a property of the authors that are selected. The authors are also nominated through governmental processes. But the final summary for policymakers. So you have this huge 3,000-page report of each working group. Then you have about a 500-page technical summary of that 3,000-page report. And you have a 100-page summary for policymakers of that technical summary. And then you have a 1-line media headline that summarizes even the summary for policymakers, right? And what most people know about climate change is from that media headline. Right? But the summary for policymakers is actually negotiated between governments. So governments nominate scientists who go and negotiate on behalf of the government. And here what is negotiated is not the science per se, but what of the science do you want reflected, which you think is policy relevant, and you want it reflected in the summary for policymakers. So you want to highlight, you want to put the spotlight on which aspect of science. Right? So there are countries who want to put a spotlight on geoengineering and geoengineering solutions to climate change. There are countries who want to put the spotlight on carbon dioxide removal. There are countries who want to focus on the social scientific aspects of climate change, equity, justice, all of these issues. Right? There are countries that want to focus on the economic, financial aspects of climate change. How much money are we going to need? Where is that money going to come from? So everybody has different interests, and so therefore these interests have to be negotiated. There has to be a basis, unlike the UN, where it's a purely political process of negotiations. The IPCC, it's called an approval process. It's not negotiations per se, because whatever you actually put in the summary for policymakers has to have a basis in the literature and in the underlying literature. It has to be in the underlying report, which is a scientific report of existing scientific literature. Right? So to that extent, it is not purely negotiated document. So anyway, after that, a little bit of a tangent. This is from the 6th assessment report. And what it shows very clearly is that there's a near linear relationship between cumulative emissions and warming. This was established in the 5th assessment report, that's in 2013. So literature that established this was in fact existing even before 2013, that's more than 10 years now ago. And it is reaffirmed again in the 6th assessment report. Right? So you have emissions on the x-axis there, and you have warming on the y-axis. You see, so you have cumulative emissions, sorry, on the x-axis. So you see there's a linear relationship. So what it means is that the level of warming corresponds to a carbon budget this is for CO2. There are other forces, other climate forces that play a role, methane, nitrous oxide being one of the main ones, but there are also others that play a role, but not as as much of a role. CO2, carbon dioxide, is the primary fossil. It's also a long-lived gas, so it stays in the atmosphere for a long time. And so you can actually estimate a carbon budget. Right? So the world has a carbon budget if it wants to limit warming to a specific temperature. Warming. So this is warming with respect to pre-industrial times. So total global warming. So the global rise in global surface temperature with respect to what it was on average in pre-industrial times. So if you take that as 0, then the 1.1 or 2 degrees or 3 degrees is where we are at, right? So that's what the targets are also all about. When we say that the Paris Agreement, all countries have pledged that or agreed to in the Paris Agreement that we will try and limit warming to well below 2 degrees Celsius from pre-industrial times. Right? And in fact, pursue efforts to try and limit it to 1.5 degrees Celsius. So that 1.5 and 2 is with respect to pre-industrial averages. Sixth was 2021. So this is from 2021. So this is from 2021. Yeah.
A naive question I always had. Did we actually have data during the 1850s and 1900s for the emissions, or is it some predictive?
No, so you can estimate. It's not measured data necessarily. You can estimate. But a lot of the emissions data really is very easily, it can be very easily estimated from resource use. You know the main sources of the main GHG emissions, at least CO2, and you can estimate them. There is a large amount of uncertainty in forestry, the data from forestry, how much CO2 is actually being absorbed. So there's a lot of uncertainty there, but you can still estimate within a certain amount, at least the anthropogenic emissions. What has happened because of fossil fuel combustion, for example, is fairly straightforward to estimate. And going further beyond that, you have paleoclimate data for some regions, some areas, it's much more established. You have fairly certain data and estimates, from ice cores and things like that. From our part of the world, paleoclimatic data is a little bit more uncertain. You have large data gaps in the tropics. But from ice cores, etc., this is fairly well established.
Yes.
CO2, right?
Estimating CO2.
But I thought CO2 equilibrates pretty fast, so we don't need it from our part of the world, right? If
we don't need it. We don't need it for this thing. But if you want to attribute, for example, so now we're moving on to from estimating how much CO2 there is. We actually know that fairly well because it diffuses very easily. You want to attribute where the warming is coming from. How much warming is India responsible for? How much warming is Brazil responsible for? Then you wonder whether sinks, etc., are important for this part of the world. But you're still talking about active sinks. You don't really need paleo data for that. You're just talking about the last 50 years or 60 years, and there it is fairly easy to estimate, even given the uncertainties from something like forestry sectors or agriculture sectors. Okay, so let me go ahead. So this is very clear that you have a relationship between warming and cumulative emissions, right? But there has been a focus on when is it that countries should reach net zero. Now, what net zero means is that your emissions and your sinks are basically balanced. You reach carbon neutrality. So how much you emit should be equal to how much you can absorb. Right? Typically, if you are being honest about it, it would mean that both of these things have to happen within your jurisdiction, within your region. Right? You can't say that, okay, I'll emit, but I'll absorb it, let's say, in Africa, or I'll absorb it in South America, or it's okay as long as as long as the Amazon is there, I can keep emitting as much as I want. That's not what you're saying. When you say carbon neutrality or when you say net zero emissions, let's say it has to be in a region. This is not always true for all the net zero targets that countries have actually pledged. A lot of them actually depend on what are called carbon offsets, which is emissions uptake. So drawing down of the emissions happens in some other place, whereas the putting out of emissions happens in their regions. But the focus really is on net zero. So this net zero is basically, it's like saying, I have a limited amount of total water supply. So, I say, okay, fine, I pledge that I'll turn off my tap after 5 hours. but I won't tell you how many buckets of water I'll fill in those 5 hours before I turn off my tap. Right? So you can actually have multiple pathways to reaching net zero. So the real question is the area under the curve. That is the real measure that determines how much warming you will have. So if you want to limit warming to 1.5 degrees Celsius with at least a 50-50 chance, a 50% probability, then cumulative emissions from 2020 onwards, till you reach zero emissions, net zero emissions, must be within 500 gigatons, 500 billion tons of CO2. Right? But so if you say take a linear reduction, this is what it is. It is the area of the right-angle triangle is what your emissions are, 560, give or less, give or take a little bit. So that's the amount of emissions you have for a 50% probability. But you can actually reach it. So you can, for the same cumulative emissions, you can take different pathways. And this is, high school calculus. It's not really very difficult to understand that it's really, I can say the US has said, for example, that it will reach net zero by 2050. Now 2050, it can reach net zero by 2050 by taking a linear reduction from now to 2050. It can decide to keep increasing its emissions and then go down to 2050 much more rapidly. Or it can reduce much more now and then very slowly go to net zero by 2050. It can do multiple things, and each of those pathways has a different implication for cumulative emissions. So just as you have different net zero years possible for the same cumulative emissions, for the same net zero year, you can have different cumulative, implied cumulative emissions, right? So the target is fungible in that sense, and it becomes a problem because all you have as declarations, and these are not even, for most developed countries, rich countries, these are all not even official declarations. They are part of their white papers, etc., domestically. They are not part of what they have communicated to the UNFCCC. Some of them have, the European Union has, but not everybody. Okay? So, so that the focus has been on net zero. Nobody is talking about really the cumulative emissions, which is quite a problem. Even though the net zero, the timing of net zero is a necessary but not a sufficient condition to determine how much warming you're going to have. So all the discussion about, oh my God, we have a climate crisis on our hands and we must declare a climate emergency and we must do X, Y, Z, and therefore you need to declare a net zero year is really hypocritical, because that's really not what you need to declare. What you need to declare is how much you're going to really emit. That's really, that if you put that on the table, we can take you seriously. That's the point. But I don't know how many of you followed what was happening, the noise around net zero targets, around climate targets was very, very high when the US came back to the fold. Right? When Trump lost the election and Biden won, when they came back to the fold, the noise around this was very high. And this is where, of course, Kerry was going around every country, Kerry and friends. So it was UK, which was the presidency. It was in Glasgow. So the presidency of the COP is where the COP happens, and the presidency keeps rotating from region to region. So the UK had the presidency for 2020. And, once the US came back, of course, it's their closest allies, UK's closest allies. And so Kerry went around everywhere saying how the US is not just back, but it is in fact now in the driving seat. It's back in a leadership position. It's going to do a lot about climate change. So let's see what has happened so far, right? What we are talking about in terms of politically agreed targets, we have, for a 50% probability of limiting warming to 1.5 degrees Celsius, we have about 85% of the total global carbon budget that is available for this is gone. It's no longer available. Right? What you have is 500. So historical cumulative emissions amount to about 2,500. And what's remaining is another 500. That's it. And that's for a 50-50 chance. If you want a better chance of limiting warming to 1.5, you have an even tighter budget. You go to 1.7 degrees, you go to 2 degrees, you have slightly higher budget, right? So there's this is 1.5, even when it was determined as a political target, was already very difficult to achieve. It is not just difficult, it was impossible. A lot of us at that point of time wrote saying that this is extremely unscientific. To set a political target that is that cannot be met, that you know today physically is impossible to meet, is very unscientific. It's not evidence-based policy making. But of course, there was a reason for that, because now there is a lot of narrative. The pressure is to put the burden of mitigation on poorer countries, and I'll come to this shortly. Right? So of the historical emissions, so this is how much you have remaining, about 17% of the historical emissions come from the US, cumulatively, 1850 to 2020, 17% from the US, about 12% from the EU and UK together. And this, those other numbers are the percentage of population in these regions. Other Annex 1 is a terminology of the United Nations. So Annex 1 countries under the UNFCCC are the developed countries. So these are the OECD countries, the rich countries of Western Europe, US, Canada, Australia, Japan, etc., plus the 14 countries of the former Soviet Union. So what are now called the economies in transition. So Russia plus the economies in transition together make what are called the Annex 1 countries. All the other developing countries, including China, are non-Annex 1 countries. They're called non-Annex 1 countries. So together, the US, UK, EU, and other Annex 1. So other Annex 1 includes Canada, Australia, Japan, Norway, etc. Those who are not part of the EU, European countries that are not part of the EU, and so on. So that's about 18% of the population, and a fairly significant amount of emissions. That's China. 10% of the cumulative historical emissions coming from China, most of them in the last 30 years, not really before that. India is 3%, again 18%. So the population in India is equivalent, both India and China is equivalent to the entire population of the developed world. Right? But the emissions are far less. The rest of the world, which includes almost the entire South American continent, the African continent, all of them together, 47% of the global population responsible for 28%. That's also rest of Asia, by the way. Not just the rest of Asia, all of South America, and all of Africa together. Right? So really, developed countries, the rich countries of the global north are responsible for a significant amount. And this is not just historical cumulatively from 1850. Even if you take from 1990 onwards, which is, why is 1990 significant, is because the UNFCCC came into effect in 1992. Right? So from 1990, you have no excuse to say that I didn't know about the problem. You agreed politically that there was a problem. You also agreed politically that the developed countries will take the lead. Right? It's a very interesting convention. The United Nations Framework Convention is unlike any other international treaty in the sense that it recognizes equity upfront. It recognizes justice upfront. It says that developed countries must take the lead, must provide finance and technology. Development is an overriding priority of developing countries, XYZ, and lots of things. And Indian bureaucrats from the Ministry of External Affairs, etc., were active players during this time. And a lot of this language of common but differentiated responsibility is a very progressive language. And if you recall the time that this was happening, this was also the time of the WTO. This was the time of the fall of the Soviet Union. So what was happening geopolitically, globally, and the world was moving towards the implementation of the Washington Consensus and towards liberalization, privatization, etc. And here you have this international treaty that recognizes climate justice and equity as important pillars on which climate action must be taken. So it's quite a remarkable document in that. And the US signed on to it, which is even more remarkable. Today, if we try to get the US to sign on to it, probably we won't have a UNFCCC. But the US signed on to it. Since then, it's another matter that the US has tried to completely dilute the those aspects of it. They don't like equity. They've said in negotiations, in fact, I've heard this said to my face that, we can't use the term equity here because there's no definition of equity. Right? So things like that. But of course, it's very much part of the convention. And so they can't run away from it unless they say that they are getting out of the convention. If they get out of the convention, they don't have a seat at the table. So they're not part of the negotiations. They can't influence the negotiations. other than through their partners and allies and spokespersons all over the world. But other than that, so they want a seat. The government wants a seat at the table, so they don't get out of the convention. And as long as they're in the convention, they have to abide by the principles of the convention. And these are, unfortunately for them, principles of the convention. So this is, in 1992, the US agreed to taking the lead in mitigating climate change. So if the US would have done their fair share, if, since 1992, they would have actually delivered on what they had said they would do, they should have reached net zero emissions by 2016. 16, right? So that's almost 10 years back, 8 years back, they should have reached net zero, carbon neutrality, if they had started action in 1992. However, this is what the US promised they will do. This is also not what they're actually doing. This is what they've promised they will do. So this is what their fair share would have been, the green one. The red is what they've promised under various treaties. So if you see, the first part is under the Kyoto Protocol, then the Cancun agreements. I'm not going to go into the details of those. And then, of course, now there's the NDC till 2030, and they have a net zero target by 2050. This is also not a promise. It's not a promise. And if at all we consider it even as a sort of a weak promise, it's a weak promise by Biden. So if Trump comes back, that weak promise is also no longer there on the table. Right? So that's their fair share. This is what they've promised, and this is what they're actually doing. Right? So there's a huge gap between all of this. And of course, so you really wonder when, so just in Dubai, a few months back, John Kerry, said, we really need to do something about climate change, and 1.5 degrees Celsius must be our North Star. And he got applause for it from one half of the room. The other half of the room was basically developing countries who were very irritated about the fact that, where does the US, how does it have the impunity to come and say this when it's one of the largest historical emitters? But anyway, moving on, this is what their narrative is, the developed country narrative for the future. And this is not just governments. The governments of developed countries perhaps have the most power to enforce the most regressive narratives, but it is academia, it is civil society, which also, sometimes if you see NGOs of the global north, especially environmental NGOs, do not really understand what climate justice means, or what developing country movements have been talking about when they talk about environmental justice, where people are at the center, right? And it's very interesting because, the poster for this talk had polar bears on it. And that's really, where the entire imagination of climate change is centered around that, right? Around a very northern, how the northern population perceives the problem of climate change. But it's no longer just northern, it's my daughter today was wondering why, I have to go in the afternoon because I didn't go to the institute in the morning. So why do I have to go? And I said, I have to give a talk. And she said, it's about polar bears. She's 9 years old. But for her, climate change is about polar bears. And so I was trying to explain to her how it's first and foremost, the problem of climate change is actually about people, right? And if you don't conceptualize it like that, you are going to have solutions to the problem that don't think about people. And that's where we are at today. But, the push, and so you see this push if you look at WWF, for example, and that doesn't justify any kind of, banning of these organizations in any country. That's not a justification for this, but there is a perspective that certain global environmental NGOs bring to the table, which are very removed. For example, environmental justice organizations in India have always fought for forest rights of tribal communities, whereas NGOs have been, global northern NGOs have been against this, saying that, it is actually encroaching on the lives of animals in forests. The granting of tribal rights will be against environmental rights of other species. So there has been this discussion and debate, not all of them, not all of the people from these organizations as well, but this has been a narrative that has been part of the entire discussion. So you have this across the board. The focus is on global ambition for 1.5. We have to limit warming to 1.5, otherwise there's going to be devastation. There's, small islands are going to drown, and there's going to be a problem. There are going to be impacts. We are already facing impacts. It's not as if we are not going to see impacts. But this entire vision of the future, dystopian future, with no human agency anywhere in it, right? So we are just going to stand there and face those impacts and die. That's not going to happen, right? We are going to try and do something about it. But that entire narrative of why we need global ambition, and this ambition is without differentiation. So you think of the world, we have caused this problem and we need to do something about it. Who is this we? In a highly differentiated world, in a highly unequal world, is there something like an undifferentiated we? And that differentiation exists across countries, it exists even within countries. So the other thing is that, no historical emissions. The push is that you have forward-looking, this is for the future. Future warming is going to be because of future emissions. Let's forget we are already at 1.1 degrees Celsius. So the entire discussions at Dubai, the developed countries were, their push was that let's not talk about what's happened before 2020. The Paris Agreement came into effect in 2020. So all that is relevant for discussions now on climate change is what has happened post-2020, the last 3 years. Right? So the world did not begin in the last 3 years. The Paris Agreement might have come into effect, but the Paris Agreement has come into effect at a time when the world is already 1.1 degrees Celsius warmer. So you can't begin the conversation without acknowledging the fact that we are already here. Now we have only 15% of the way left, and how difficult that has made the situation. The other narrative is that you're asking for equity is actually a barrier for ambition. Right? So if you demand climate justice, an older argument was that countries, India, South Africa, etc., talking about climate justice was to hide behind the fact that they don't want to take climate action. You don't want to do anything about climate change, and so you simply use equity as a shield. You say, okay, we have not caused the problem, so we won't do anything about it. And now the entire thing is, okay, fine, equity, but you really, we don't have time for this discussion. Let's discuss that later. Right now, we really need ambition for 1.5. Right? The urgent thing is to do something about climate change. We'll deal with the problems of equity as and when, and there are, of course, many opportunities to do so. So what is it that we need to do? What is this ambition? We need global reductions. We need 43%, and all of these are now part of political decisions, these numbers that you see. Many years ago, I think it was one of my first, I was just out of grad school, one of my first talks that I gave on climate change, and it was a presentation of a model that we had done for mitigation, burden sharing across countries. And it was attended by a lot of the then negotiators. So, Pradipto Ghosh, Ambassador Das Gupta, etc., all of these people who negotiated the convention and were part of the Kyoto Protocol negotiations. And Jairam Ramesh was the minister at that point of time. They were all there listening to this. And they were very, some of them, not all of them, some of them after the talk were very, in hindsight, very patronizing, saying, oh, very good work, excellent, academic discussion. But you see, the negotiations are not really about numbers, They're really about language, they're about narratives, they're about, what kind of language, what kind of narrative you can build. They're not about numbers. Nobody is interested in your calculations, in your equations and things like that. That's not going to be part of it. Right? And when I first attended negotiations, I also was very surprised. Like, what are these guys talking about? They spend hours negotiating a comma, whether a comma should be before this word or it should be after this word, whether there should be a semicolon or a full stop here. I was like, what a waste of time. Right? But, now if I think about it, I think both of us have been proven both right and wrong. It's about both. It's about narrative building, but it is increasingly becoming about numbers. And the numbers themselves are creating, helping to construct a certain narrative. So these are the global numbers, right? And these come from the IPCC reports. And the IPCC, being such a huge international collaborative effort, is considered as an authority on the question of climate change. So 43% reduction by 2030, net zero by 2050 for 1.5 degrees Celsius. You need to peak emissions very soon by 2025. You need tripling of renewable energy. So you have multiple targets, multiple numbers that are being set ostensibly at the global level. They're not saying India should do this much. They're saying globally, this is what we must do. But where are these numbers coming from? And these numbers come from, I don't have time. I've run out of time. How much time do I have? Okay. So I'll take, because I would prefer to have, and if you have questions in the middle, just stop me and, it'll be also better that way, perhaps. So some of all of these numbers come from what are called integrated assessment models. Right? See, these integrated assessment models are an integration of multiple modeling approaches. One is there are macroeconomic models that are part of this, which is where you get the GDP numbers from, where the demographic numbers are put in, and they are typically, in fact, solely, given the current set of models that are being used and assessed, are neoclassical in nature, meaning their approach to economics is neoclassical in nature. They are a certain view of economics. And it's not so it's very, modeling in the economics and the social sciences is very different as compared to modeling in physics, for example. It's like, if you call up a physics department and ask them a question about, the first law of thermodynamics, something like that, I don't know, you'll get the same answer. But if you call up an economics department and ask them about, marginal utility theory or something like that, you're likely to get 10 different answers, right, from 10 different economists in one department. So it's not the same. There is a lot of contestation here. But you have this one dominant view of economics, like you have a dominant view of economics in most economics departments today, across the country, across the world. You'll have this one or two sort of alternative departments have some amount of heterodox economics around, but otherwise it's one dominant view. Similar, so that's one view from which you have the economic models that are coming. Then you have energy models, which are basically trying to find out what is the most cost-effective way, what is the least cost way. So it's least cost optimization. What is the least cost way to achieve emissions reduction? So which technologies, what is the so the output is a mix of technologies. So how much do you need to reduce coal, gas, oil, how much more renewables, how much nuclear, how much X, Y, Z, etc., how much carbon dioxide removal. So you have those dynamics. And all of that in some form of global optimization. So where it is cheapest to reduce, when it is cheapest to reduce, so across a time period, across the entire spatial scale, and how it is cheapest to reduce. So all of these three questions answered in one very large black box optimization model. And because now 1.5 degrees Celsius has become so difficult just to achieve through any kind of technology substitution. So I get rid of coal and I put renewable energy. Even if I do it the fastest I can globally, 1.5 is still out of reach. Right? So the only way you can actually reach limit warming to 1.5 degrees is draw down carbon dioxide that is already there in the atmosphere at very, very large scales that are currently unproven technologically and not scalable commercially. Right? So because you need that, and that means you need land dynamics. Yes. Yes. So, on paper, the IPCC claims that it doesn't do the modeling. Right? It only assesses what people do in terms of models. But the IPCC, there's a whole process through which the IPCC, in fact, participates in and calls for certain kinds of scenarios to be run. Because what happens is the scenarios that are produced here, some of them are chosen to be used as inputs in the Earth system models. Right? So this is what I call Earth system feedback. Now the Earth system models is where the climate dynamics are modeled. And those are much more expensive. They're large models. They're much more expensive to run. So you can't run thousands of scenarios for every increment. There's some sensitivity also. So if you're running a model for, let's say, 1.7 degrees Celsius warming, it doesn't make sense to run a model for 1.8 degrees Celsius because just simply the sensitivity at the two is, that is so overlapping that in terms of time and cost, it makes no sense to do those runs. So they are very picky about which how many models they will, how many scenarios they will run, right? So, so you have, so all of these then go into the Earth system model. So there is a lot of influence that IPCC members, and you have the same set of suspects all around. It's a very small insular community, modeling community. And so, they're all the same people everywhere. But theoretically, IPCC doesn't, it only assesses. Yes, typically, yes. The people who do the 1, 2, 3 there are different from the people who do the Earth system modeling, typically. So here you have the physicists, the meteorologists, all of them here on the Earth system part. The first one you have economists, the second one you have engineers, the third one is a mix of economics. So it's a newer thing, and a lot of people have gotten into it. A lot of geologists have gotten into the vegetation models right now. So you have also multiple disciplinary biases and influences coming into all aspects of this, right? So for example, in the vegetation models, you have conservation biologists also playing a role. So you have, and in terms of the view of nature, if you take conservation biologists and you take meteorologists, they have very different views of nature. Very, in fact, conflicting views of how they view the man-nature relationship. Right? Meteorologists have always considered nature to be inherently chaotic, something that mankind has to be protected from. Whereas conservation biologists have not all of them, but have a view of a much more harmonious, benign natural system in which human interference, anthropogenic interference, and the breaching of planetary boundaries has in fact created problems, right? And these are conflicting views, but they all, so that's what makes the IPCC process actually quite interesting, because it's this remarkable collaboration across different disciplines, sometimes disciplines with opposing views on a similar phenomena. They come together and at times end up giving very confusing results, outcomes, but nevertheless, it's there. But these IMs have particularly high amounts of influence. Especially in working group 3, if you see the amount of media footage, media coverage they get, the amount of space they get in the summary for policymakers, and it's a very powerful lobby in Europe that is really this thing. So if you look at, there are, in the 6th assessment report, there were 21 models that were assessed, scenarios from 21 models. One of those models came from a developing country. 20 of those models were from developed countries, right? Out of the 20, 16 from Europe itself. One from Brazil, the developing country one from Brazil, which was a spin-off of an Austrian model. So it's not an original Brazilian model. So it's the same models being run. And 96% of the scenarios coming from these 20 models from the global north with the same set of views of the world. So because any of those, if you look at the first 3, you can say, okay, human agency doesn't have too much impact on how you will, how you sort of represent cloud feedbacks and things like that. But when you talk about economics, when you talk about energy choices, all of this has some socio-economic, underlying socio-economic dimensions and assumptions that are very much part of this. And this is what it is. So you have, what they do is, they use these models, then they define a baseline, say that how is it, how does the world develop over the next, not just for 2200, right? So it's impossible to predict GDP for the next 2 years, 5 years, or whatever. 5 years is a planning horizon. That's at most how far you can go for GDP projections. But these guys do 200 years of GDP projections. So how reliable those models are is a different question altogether. But I'm going to skip some of this. The SSPs, they are not relevant. I'm just going to go directly to the results, right? So what we did was we assessed 556. The IPCC assessed at the global level, they assessed 1,200 scenarios coming from these models. Out of those 1,200 scenarios, 700 corresponded to the Paris Agreement targets, right, which is 1.5 and 2 degrees Celsius. The other 600 scenario or whatever 500 scenarios were for higher temperature levels, 3 degrees, 4 degrees. Okay. Of this 700, around 550 scenarios had an underlying 10 regional classification. So what these scenarios are, they are global scenarios. They're global models, sorry, not global scenarios, global models, but each of those models has an underlying regional classification. Some are more disaggregated, some are more aggregated. So some only do it at a very large sort of continent regional level, so 6 regions only. And in all of these things, only the OECD is separated out by economic criteria. Right? Everybody else is a regional category. The OECD is the only economic category. So it doesn't matter if China is producing for the rest of the world. It doesn't matter if India is, digital powerhouse at XYZ, whatever it is that we think about ourselves. For the developed world, we are simply, forests. We are simply a tribal society living in forests, meant for absorbing emissions that are emitted in CO2 that is emitted in the global north. That's the view. So if it's, maybe this is not the right crowd in which to crack this joke, but it is really colonial anthropology revisited in various forms. But so we did an analysis of this 550 scenarios, and what it shows, where is the world in 2050? So per capita GDP, and forget the labels, C1 scenarios is simply a label from the IPCC. It's the 1.5 degrees Celsius scenarios. In the 1.5 degrees Celsius, 50% probability of 1.5 degrees Celsius, these are the projections for per capita GDP, right? Which is, so you see sub-Saharan Africa going from $3,000 per person to $9,000 per person. And you see North America going from $54,000 per person to $72,000 per person. So South Asia is somewhere there, 6 to 18,000, right? So there's a huge disparity in projections. So the rich get richer. And when we first published the preprint for this paper, before it was published, it's now finally published. But before, when it was a preprint, there was a lot of pushback from the modelers saying, oh, but there is actually a higher increase for sub-Saharan Africa as compared to North America. We're trying to, this is realistic, this is pragmatic, sub-Saharan Africa, but there is a higher increase. If you see it as true, there is a higher increase, right? But 1 rupee to 2 rupees is a much higher increase as compared to 100 rupees to 150 rupees. It doesn't mean that I'm much richer with 2 rupees now, just because my income has increased by 100%. So so if you look at what happens in 2050, you remember we have to meet the Sustainable Development Goals in 2030. Right? But what happens in 2050 is sub-Saharan Africa and large parts of South Asia, which is us basically, still stay far below what would be considered a reasonable standard of income by then, and there is no convergence. So you see no redistribution at all, right? And this is a basic element of how the economic modeling is done. It's basically estimating a Pareto optimality. And Pareto optimality means that you can't make anybody, it very crudely would imply that you can't make somebody better off by making somebody else worse off. So I can't make sub-Saharan Africa rich by redistributing wealth from Europe to sub-Saharan Africa. You might talk about colonialism, etc., but you can't redistribute wealth in that form in the logic of neoclassical economics, in the logic of Pareto optimality. So if sub-Saharan Africa has to grow rich, Europe has to grow rich faster, even richer, even faster. And then wealth will trickle down to sub-Saharan Africa. Right? So that's the logic in which the economic modeling is done. And of course, because you don't have any time left for 1.5 degrees Celsius, you have no emissions left, you have no time for equity left. So you have no time for the convergence to actually happen, irrespective of what it is that you do. And this holds true across all scenarios. So the first graph was 1.5, this is 2 degrees Celsius. The GDP projections don't change, right?
Hi.
Yeah.
As you said a while ago that these use some modeling for the GDP, which they are extrapolating to 30 years and even 2200, right? You said. But as you said, we can't quite trust these models. So what is the conclusion you want to draw from? I'm not.
No, so one
sure.
is, what has happened is you might not trust the GDP numbers for 2050, right? But what they are telling you, what the UNFCCC decision is saying, is you need to reduce emissions by 40% by 2030. Right? And that 43% number is coming from this global model. Now that 43% number has come from on the basis of calculations done in these models, which include GDP as a basic assumption. So then, what it eventually would imply is, if you need 43% reduction at the global level, the best way to achieve it is India does so much, South Asia does so much, Sub-Saharan Africa does so much, etc. etc.
GDP wise.
And if they, not GDP wise, energy wise, I'm getting there. If they do so much, but if they can do so much based on these underlying assumptions, right? So if you want to mitigate, if you want India to mitigate XYZ amount, right, that XYZ amount has to be tied to energy use. But that energy use cannot be determined without any other drivers. And so one of the drivers to energy use, the main driver in fact, is GDP. And consumption, which I'm getting to next. This is consumption, per capita consumption of goods and services, right, which is a component of GDP. So you have, then this is even starker. Sub-Saharan Africa going from 1,000 to 3,000, South Asia going from 1,000 to 4,000, and North America, etc., going from 35,000 to 59,000. Right? So there's a huge disparity in the per capita consumption of goods and services. And there's also internal inconsistency. Because if everybody is, so the thing is, you have now what is happening is, and this happens even more so, that developing countries become producers, developed countries become the consumers. This has always happened, but there has been a shift in terms of whether it was raw material consumption, where the production happened. So you extracted raw material, took it back, produced it, and then the markets were developing countries. But things are changing, especially in relation to Sub-Saharan Africa and areas, other areas of South Asia, maybe not India so much.
So it's something I didn't understand. Yeah. Is this part of the model which is explicitly stated and you're just bringing it out, or is this a calculation on top of the model pointing out that the model assumes?
No, this is a variable that comes from the model directly. These are the results that they have reported. Okay. So this is not our estimation. And this again also remains the same in 2 degrees Celsius. So irrespective. So, it's one thing to say that you have a very high mitigation burden. And so you won't be able to mitigate if everybody becomes rich, right? So one way of looking at it is that if you become rich, you want more amenities. You want cars, you want housing, you want air conditioning, you want X, Y, Z. And if everybody becomes rich, you can't, then you won't have mitigation. So one way, the cheapest way, in fact, to mitigate climate change is to maintain poverty. It's a very perverse argument, but it's not an argument that they're making in that manner. But I can interpret the results in this particular way. And I'll tell you why I'm doing that very shortly. Because it doesn't matter, when your entire view of how we should mitigate is based on how would it be the easiest or the cheapest? What would be the cheapest way to mitigate? If that's the focus of how you're going to mitigate, then an equity, justice, the needs of developing countries, none of these things matter in the way in which you're projecting the future, then it doesn't matter whether your temperature target is 1.5, 1.7 or 2 degrees Celsius. The minute you have a slightly relaxed constraint on emissions, the relaxation benefits the richer countries. It doesn't benefit the poorer countries. So at higher temperature targets, the constraints on developed countries reduce in these models. They don't reduce on developing countries because it still remains the cheapest to mitigate in developing countries. Right? And it, so progressively what would have been really quote unquote difficult for developed countries, their constraint eases faster. Yeah. So if it is, for example, is afforestation cheaper than moving from gas-based power production to solar power panels, right? So is afforestation in Africa cheaper as compared to, let's say, moving to electric or public transport in the US? If those are my two options, then obviously the cheaper option is afforestation. So I have this huge list of options, which are my mitigation options across the world, costs across the world, and I'm optimizing across all of this just based on costs. This is energy. So if you look at that's gigajoules per person per capita energy. So on the right, the red bars are all developed countries. So per capita energy in 2050 remains much higher for developed countries. If you see South Asia is somewhere around 30, 40. So India currently is at around 23 gigajoules per person. Right? So we will go up to 40 gigajoules per person. That's the projection up to 2050. Sub-Saharan Africa will remain at around 20. Right? Developed countries will continue to remain at way over 150 gigajoules. And this translates to even fossil fuel consumption. Now, this is a complete violation of the treaty that you have agreed to, both Paris Agreement and the UNFCCC, because there you said that developed countries have to take the lead, right? But even fossil fuel consumption, everybody reduces. It's not as if but you look at where we reduce from. So South Asia goes from 14 to 1. Latin America goes from 3 to 1. Right? Sub-Saharan Africa goes from 3 to 0. And, the North America, for example, China goes only to 5 and North America goes from 38 to 2 in coal consumption. And similarly, you have similar results in oil consumption and gas consumption, but this is total fossil fuel. If you look at total change in fossil fuel consumption between 2050 and 2020, right? Everybody sees a change. Everybody, for 1.5 degrees Celsius, everybody has to get rid of fossil fuels. But we have to get rid of we have to get rid of fossil fuels from very low base levels of fossil fuel use in the first place. So it's like saying that you decarbonize even without fully carbonizing. Whereas for the developed countries, and you see North America in 2050 continues to use more fossil fuels as compared to developing countries. So 30 years from now, America is still allowed to that historically we have emitted nothing. And this, of course, is combined with the fact that most of the carbon sequestration, carbon dioxide removal happens in our countries. Right? So if you see the blue, a large proportion of it is happening in non-Annex 1 developing countries, largely in Africa and Asia, and of course Latin America. Right? So most of it, again, across different models. And as a result, even near-term mitigation is much, much higher in developing countries. So it's saying in this decade, now we are already at 2024. So by 2030 itself, Africa is expected to reduce its emissions by 80%. From the pittance that they are currently emitting, they're supposed to reduce their emissions by 80%, which is much higher than what Europe and US are expected to reduce their emissions. So this is what the models say, and it's they are now, of course, nobody really brought it out so clearly till now. We've had theoretical critiques of models for a long time. From Amartya Sen's time, he has written 30 years ago a critique of the integrated assessment models. Right? So and so it's been there for a long time, but the fact that they actually produce these outcomes, because theoretical critiques are fine for academic discussions, right? But when a number gets picked up by the political leadership and gets put in a decision which you are committed to, which your government has signed on to, you need to know what lies beneath that number. What are the outcomes that lie beneath that number? What does that number imply for India? And this is what it implies for India. Energy poverty, income poverty, and huge amounts of mitigation burden, despite the fact that you have not caused the problem in the past. So anyway, so what I don't have time at all for was the next part of my presentation, which is an alternative to this modeling. So I'm just going to rush through it. But anyway, so what this is some summary of why why we have these unequal outcomes from these. One is, of course, it's embedded in the economic models itself. You freeze current income inequalities. On top of that, you impose unequal baselines, unequal mitigation burdens. And there are all kinds of assumptions made for technology. So what you say is, okay, when you say that, you're not even projecting GDPs that will allow for basic poverty eradication in large regions like South Asia and, Sub-Saharan Africa, the response we have gotten from modelers is, but it's not pragmatic. This is not historically, if you extrapolate the historical rates of growth, they are not going to grow at rates which will allow for full poverty eradication. So we are just representing reality. But that doesn't hold true for technology. Right? You have huge amounts of speculative technology that is part of the models for carbon dioxide removal. Amount of afforestation that will actually need to cover more than the total area under agriculture today. Right? Huge amounts of assumptions about people moving to eat Lancet diets, food systems changes that are likely to happen. You assume that developing countries will achieve efficiency when you know that efficiency achievement requires scales of production. Right? The small and medium scale industry, I don't know how many of you have seen small manufacturing clusters in Karnataka, for example, pellet makers, small tanneries. It's very difficult to improve efficiencies there simply because there is no capital to be able to do it. You need, efficiency improvement requires scales at which production happens. So all of these assumptions are unrealistic and they're imposed on these models, but they are not called, the modelers themselves don't think they're unrealistic. But if you ask for income equalization, they think it's unrealistic. Right? So there's a lot of lip service in a lot of the IPCC reports saying we need transformational change. To address the problem of climate change, you need transformational change in economic and technological systems. But when they actually model it, the only transformation they assume is in the technological systems. There's no transformation in any kind of economic system, whereas it's not clear whether you can even have technological transformation with economics as usual. You might have to change the way in which economics happens, and this discussion has begun at the political level. The academia here is lagging behind because reforming multilateral banking, financial systems, etc. has already started. People have started talking about the BRICS bank and things like that. Whereas, it's not very much, it's not even part of the academic discussion within Indian academia, within the global South academia. Because a lot of the academia in the global South really revolves around what are the trendy woke research questions that the global North is looking for. And when it comes to applied sciences, when it comes to engineering, economics, etc., those kinds of things, you really need to ask questions that are relevant to conditions and circumstances around you. It's not, there are of course universalities here, even in these sciences, but the questions of whether there is applicability on the ground is really very local and regional. But those questions are really not being asked. So anyway, so I'll stop here, I think, and open up. We have, and I'll share the presentation. So some of the things that I plan to cover on how we have a different view of the world, and that paper that has just been accepted actually of a new scenarios framework that moves away from this neoclassical understanding. It still does a quantitative estimation of the future and what the future looks like, but it's premised on achieving both equity and climate compatibility. What we show is 1.5 degrees is still infeasible. So you either have equity, you either have high levels of infeasibility for developed countries, right? If they have to stay within their fair share, they have to get rid of all their fossil fuels in this decade. The US, Europe, it's not going to happen. Even if they have political will to do so, the impacts of doing it so fast are going to be high in their own societies and on their own poor as well. So it's not going to be feasible at that rate. It's all right to ask for it as a political strategy, but realistically speaking, it's not going to be possible for them. But so with the highest possible feasible ambition from developed countries, allowing for equity and development in developing countries. But that doesn't mean that, of course, large developing countries don't have climate burdens. They do, but they're gradual. All of this would be still possible at around 1.7 degrees Celsius. 1.5 is not in reach. So this is what some of our work that is upcoming shows, with a different kind of approach to modeling, not the integrated assessment modeling approach. But maybe I'll just, so this is the basis on which we had the new modeling. So, necessity over pragmatism, equity is now urgent. So the question is not about whether climate change is urgent, and we deal with the question of equity later. Because the problem of climate change is urgent, equity has become even more urgent. right? You need to reduce vulnerabilities of people. You need to ensure that they become climate resilient. You need to ensure that people are protected, which means that that question of equity has become even more urgent than less urgent now. And it is, of course, much more important if you consider equity as a question that's more important than simply, some basic cost efficiency. Then, of course, you have very, very different outcomes. So I really don't have time, and I'll really, run through it and mess it up. So I'll stop here, and maybe we can have a little bit of interaction instead of going ahead.
Hi, I have a question about how you're defining cost in these models. Not you, I mean the model makers. So, like, is the cost of life and quality of life somehow included in these models at all?
No, not in these. So you don't have. You have so cost here is basically sort of accumulated over a period of time price of mitigation options. That is what cost means in these models. The cost of life, etc. There are impact models that are separate from this. So there's another set of models which are not included here, which look at impacts of climate change. There you have estimations of cost, the burden of disease and those kinds of things. Those things are included in those models. Sometimes in some of these, like the original model from Yale, had this kind of a what they optimized or what they tried to balance was this: the abatement cost, which is the cost of mitigation, versus the cost to GDP. Now, that's not cost to life, that's not loss of life, etc. But if you have impacts of climate change, how much does it reduce your GDP? Right? And so, at what point of time does it does the mitigation and adaptation cost balance out? So, the 2 degrees Celsius, that number, okay, comes as, part of it is from other discussions, but, some of the first proponents of that 2 degrees Celsius were also arguing this, that this is the temperature at which you actually balance out the adaptation and mitigation cost, which means that if you try to limit emissions to below 2 degrees Celsius, the mitigation cost is too high. If you don't mitigate enough and go above 2 degrees Celsius, the cost of impacts is too high. So 2 degrees is the optimum.
I wanted to understand if there's an analog of the IPCC within Asia. I mean, I can imagine that we like to complain about the West, but if we look at within Asia, is fair share understood?
I would say yes and no. Within Asia, of course, China is a different player altogether. If you look at the global carbon budget, China has still not used up its share, but it's very likely to get there. It will use up its full fair share, which is quite a lot because China is a large country, large share of the population. But the fair share argument is something that India and China have both made at different points of time and still make. India now still much more strongly. China has sort of withdrawn from that debate, from that kind of position a little bit, because it's very clear to them also that they're going to breach their fair share. They're not yet done it, but they will. So they've muted. But if Asia had a fair share, and whether there is some understanding of an equitable distribution of Asia's fair share, etc., that conversation has not happened amongst Asian countries because there's a huge amount of division within Asian countries, even in the negotiations. So Asia doesn't negotiate as a bloc. There are blocs that negotiate under the UN. Asia does not. India negotiates with BASIC, which is Brazil, South Africa, China, India. That's a 4-country group. So 4 major developing countries. India negotiates with LMDC, which is like-minded developing countries, which has Pakistan in it, which has China in it, but it has Bolivia, Saudi Arabia, Venezuela, Cuba. It is a motley group of countries, a very different grouping, but India negotiates very strongly with the LMDC. India is also part of the G77 bloc, which is a very broad bloc. But it's not, there's no Asia bloc because there are too many differences across the region. These guys club us together in South Asia, but if you dig into the models, a lot of these models are largely India. They'll separate out India, they'll separate out China, and all of the other countries of Asia, they'll club in the rest of the world. So, but to answer your question very shortly, no, there is no common understanding. There's a much more common understanding between India and China than there is with the rest of Asia.
So you were mentioning that some of these or most of these mitigation models are focusing on the technology aspects than the socio-economic stuff, right? So are there any models at all which propose different socio-economic whatever workings, which then actually show some good results when it comes to the mitigation?
Yeah. No, so let me rephrase that a little bit. It's not as if they don't look at socio-economic and they look at only technology. They look at both. But they assume that the socio-economic situation will not change, but technology will change. That's what they project. That's because they have a certain view of economics. Now, whether there are models that are different, unfortunately, the heterodox economists or other kinds of social sciences that actually study equity, justice, etc., don't do quantitative modeling. It's like a hard separation within the disciplines of people who do this versus people who do that. They don't like people who do. They don't trust people who do the quantitative modeling, right? So you have very few of the alternatives in quantitative terms. That's why so far you've only had theoretical critiques. There are a few who try to do it. Like for example, in some people now have started trying to change the way in which these the production functions are set up in these models to see whether degrowth is possible. Degrowth has become a very big thing in Europe. So whether degrowth is possible to model. So they've done a paper in which they've modeled degrowth for Australia and seen whether it impacts equity and things like that within Australia. Right? So there are a few examples like that, and we have a model now where we don't use the neoclassical macroeconomic welfare sort of utility maximization model. We actually look at GDP growth in terms of what would be required for reasonable levels of human development across various human development indicators, not just infant mortality and life expectancy, but also infrastructure. So water supply, sanitation, number of people living in slums, death due to air pollution. So if you consider all of those and infrastructure variables as well, what is the reasonable level of income? Because across all indicators, you see sort of a saturation for energy. So what is a reasonable level of income and energy that you must ensure for all countries? Right? You can't say that sub-Saharan Africa will stay at 20. Right? If the minimum amount of energy that you need for achieving levels of development that are comparable across comparable to developed countries, then you at least need, you don't need 300 gigajoules like Canada, right? But you at least need 80 gigajoules. Then you can't have modeling projections that say that sub-Saharan Africa will remain at 20. You have to see what happens if sub-Saharan Africa gets to 80, right? Then how much mitigation burden does the rest of the world need to take to ensure that sub-Saharan Africa can get to 80 gigajoules? So you reverse the question. You don't say what happens, what is the mitigation burden if the world doesn't change. You say that, okay, if the world has to change to ensure that people get what is their rightful share, then what is the mitigation burden? What does the world look like?
You're saying currently those kind of models are on the lower side, or
they don't exist.
They don't exist. Yeah. The other question that I had is there a country, or are there some countries maybe towards the west of us, but maybe not Europe, who are doing better on this moving towards net zero?
Moving towards net zero? No, so if you look at those who are actually moving towards or close to net zero, are some of the poorest countries in the world. and it's really a result of poverty. It's not a result of mitigation. If you look at where the highest mitigation efforts are happening, right, renewable energy, etc., technology, that's really places where emissions are increasing in the developing world. So it's China. China is the highest deployer of renewable energy. Right? The total installed capacity of solar in China is equivalent to the total installed capacity in the rest of the world. So that's the scale at which they're deploying technology. Okay? And if you take the 5 highest deployers of renewable energy, 3 in that list are developing countries. There's China, India, and Brazil. Okay? And you have the US and Europe there. But at very different levels of per capita income across the 5. India is the lowest in all of that, but is the 3rd highest deployer of renewable energy. Right? Just simply because the scale of the country is very high, the total revenue is very high. So, in that sense, if you look at who's doing very well at very low levels of income, India would be one of the top countries that are doing very well just in mitigation terms. But that's, so, it's a very tricky metric in that sense. So, because you have high deployment of renewable energy alongside a higher increase in fossil fuel use as well. And that's a result of development, increasing energy demands and things like that. You have that across the oil exporting countries are a different question altogether, right? You take Saudi, Bahrain, all of these countries, Qatar, huge amounts of energy, per capita energy use, and high levels of dependence on the oil sector, right? Very low levels of economic diversification, but not necessarily developed per se. Right? You would, if you compare, somebody asked the other day, I forget, if you do a comparison between, or it was in a book, it was in one of the, so if you do a comparison between the Saudi Arabia and Norway, who would you consider a developed country? Which of them do you think is developed? Right? And the answer is, everybody would give is Norway is developed. But if you look at the per capita incomes, etc., they're very similar across the 2 countries. Yet across a lot of indicators, there is a certain reason, a perception why you would consider Norway as more developed. Right? Saudi still has a lot of challenges to overcome, and the economic dependence is solely on one sector. So the doing better, doing worse is a very difficult question to answer in that respect. If you actually are doing better because you're doing efforts, it would be because you're also developing and your energy demands are increasing. Otherwise, it's simply a result of poverty.
Just to add a point which I know has been discussed a lot, but just to put it out there, of course, you were discussing this issue of inequity in global scenarios, but there's of course internal class-based inequity within within countries, within India, for instance. So I was wondering if, in these other alternative models you do, whether there's also a radical reconception of how inequality within countries has to decrease, or whether you feel, which might be a valid position, that that's a question which should be addressed, which should be placed secondary to questions of global inequity, because nation states are still the paradigm within which we work.
Now, I don't think it's necessarily a secondary question, or it should come later. I think it is. I don't think it's a binary at all. And if you cannot deal with the problem of domestic inequality, there's very high levels of it, in a situation where imperialism dictates the terms also. So in that sense, global inequality has a role to play in how much space you have to deal with domestic inequality. Right? So if you don't fight the fight globally, the space you have to correct the problems that you have domestically also shrinks. And so that, I think, is the perspective with which I would look at it. I would not say that this comes first, this comes later, but that one cannot be done. The flexibility you have to deal with what is perhaps more immediate to you, which is domestic inequality, that space itself shrinks if you have increasing influence of or increasing pressure to do something that you're not yet prepared to do, right? Increasing energy costs, for example. How do you, if they're being imposed due to higher mitigation burdens, dealing with domestic inequality becomes that much more difficult. Global models dealing with domestic inequality, and this is a lot of these fellows, having faced criticism now, and this criticism of models and this thing, because they've tried pulling a fast one and putting it into the UNFCCC and all of that, everybody woke up to it, right? And so now once, India made a big noise at the COPs about the models and the problems with them. The LMDC spoke up, then China spoke, Saudi spoke, and now the Africa group of negotiators has in fact released a statement to the IPCC saying you change this in the AR7, otherwise you're going to have trouble on your hands. Right? So it's become a big political thing now. And the response that you have from modelers is that we will deal, so their understanding of inequality is you don't need to deal with the global inequality. The only inequality that you'll address is domestic inequality, class to a certain extent, but largely the question of gender, the question of indigenous communities, etc., which they think have local domestic dimensions, which are politically much more easy for them to deal with. Saying that you have a gender issue, you deal with it. Right? So the response to that, in my opinion, is not to say that that's a secondary problem, but it's, how is it that I solve the question of women having to walk for ages and, having to face lives of extreme drudgery because of lack of modern cooking fuels or lack of drinking water supply or water supply in general or sanitation, if you don't give me access to energy, right? If you don't let me build infrastructure, if you don't let me build housing, and all of this you're constraining by doing all of this, and then you're telling me you solve your gender problem. Right? So it's not a disconnected question in that sense. In the models, it becomes difficult to deal with, but one of the things that I have done in the past is to see whether, in what way do you actually plan your investments in, so if you have to have more renewable energy, somebody has to pay for it, right? The government has to find the money for it. And it's not going to all be new and additional money. There's no magic, there's no beanstalk here that's giving you money when you want it for whatever purpose you want it. So you're going to have to you're going to have to rebudget your expenditure. But how you rebudget it, where the money comes from. If it comes at the cost of welfare schemes, if you say that I'll reduce fertilizer subsidy and give that subsidy for renewable energy. If you say I'll reduce Narega expenditure and give it for renewable energy, then you're going to in fact increase inequality while you mitigate. Right? But if it comes from taxing activities that are, that would be considered luxury activities, or if it comes from rebudgeting from other kinds of expenditure, defense expenditure, etc., things like that. I mean, I don't know how to do it, whether or not that will fly, but from progressive taxation and those kinds of things. So you can do it, using certain national accounts tables and things like that. So the way in which you plan investments, with even domestically in the sector, can have different impacts, distributional impacts for class-based equity within the country. So those things have been done domestically, not at the global level.
That a lot of what you said now and in the talk also was about mitigation efforts. Of course, adaptation efforts are places where local efforts have local consequences. Do you feel that could be something that locally could be used to have or support movements for equity locally? Because that's something where you can say you have policy which is designed to make the society more equitable. And secondly, also for countries like India, at some point of time, you pointed out there was an equilibrium of 2 degrees between costs of adaptation and costs of, but of course, that's very unequally distributed. So, would it make sense to have policy focus more on questions of adaptation, again, because local efforts have local consequences in that regard as opposed to mitigation?
Yeah. No, so let me just again clarify that 2 degrees Celsius equilibrium is not, I don't believe that's correct. It comes from Nordhaus, actually. So he is the one who argued it. And it is a problematic way of looking at the entire question, because impacts are unequally distributed. And yes, I completely think that adaptation is where we must focus our policy efforts. It's always been a challenge, because we really don't know where development stops and adaptation begins. What is that line that separates development? So if you have higher levels of development, better incomes, etc., better ability of people to cope with disasters or cope with variability, you have more resilience, you have that. So development itself leads to reduction in vulnerability. Right? What is adaptation over and above that has always been a little challenging, unless you, at the economy-wide level. But at the sector-specific level, you can of course discuss it. What does adaptation mean in agriculture? right? How is it that you integrate scientific understanding of weather variability into actual farm practices on the ground? What does climate resilient infrastructure mean? Climate resilient housing mean? What does coastal, if you have to have coast protection from coastal flooding, what kind of infrastructure do you need across India's coastline? So those questions are really very concrete ones. And that is where our policy focus really must be. So if we really want to change the discourse, that has to come from developing countries. What is it concretely that we mean about adaptation? Put that on the table, early warning systems, coverage for early warning systems. You know, India and China don't make a big deal out of it because we provide it for the regions in which we are. But if India and China don't make a noise about something at the UN, then no other country can make a noise about it, right? So that, because it is a matter of power. But you take other countries, you take Zimbabwe, you take Pakistan, all of these countries that don't have systems, observational systems, local or weather observational systems, and the entire continent of Africa, all of these capacities need to be built in all of these regions. Right? And so that becomes a very clear requirement for adaptation, for reducing loss and damage, all of that right up front. But you need to push it, make it into a big enough issue, and you need big developing countries to put it on the table to make it a big enough issue. That unfortunately is not happening because the pressure is so much on India and China to mitigate. A lot of our political response to it, both in India and in China, has been about, see, this is what we are doing for mitigation. It's big declarations, big announcements about mitigation. But to put adaptation on the map in that manner would require this kind of push from all of us. Even Brazil, you see, Brazil is going to host the next COP. It has a progressive government in place. After the previous government that was a denier of climate change, you have now Lula back in power. But it's all about mitigation. Of course, and they're going to hold it in Belém, in the heart of the Amazon and things like that, but it is all mitigation centric. So even a progressive government in a developing country doesn't think it is, doesn't know how to put adaptation like that on the map. So it's a challenge, but I agree with you completely that we must do it.
Are there other questions?
Yeah, so if one just looks at the extreme events in global climate in the last 2 or 3 years, there are many more events than one might have guessed based on the previous expectation of how global climate change is occurring. So is there a re-evaluation of the rate of climate change? This number 1.5 was peaked at one time, but it seems to be underestimated based on current data. Would that be fair?
Yeah, so 1.5 is not even an estimate. 1.5 is a target, which we are very likely to breach. Right? Yeah. But if you want a tighter target than that, because it is very clear what you're saying is that the impacts and the number of events that we see, which can be classified as extreme in nature, seem to be higher. Whether individual events can be attributable to climate change is a different question. But at least the frequency seems to be higher in the last few years, is very clear. There is constant reevaluation. To be fair, in the sense of, whether there are a lot of feedback effects, for example, that we really don't know enough about. So the more we know about them, the better we model them, the better we can have predictions about extreme events and things like that. So there is constant reevaluation. The only way in which you can revise a target is to make it tighter. And the unfortunate part, story of the situation is that politically it's going to be, even the 1.5 is impossible. So a tighter target than 1.5 is going to be politically impossible to negotiate. So scientifically, you might say that, at 1.1 itself, you have so much more loss of life than you would have thought possible, right? But, loss of livelihoods. It's not just immediate loss of life, but, long-term impacts. But even 1.5 seems difficult, despite overwhelming evidence to the contrary. Okay. So it's not, okay. I don't think it's a scientific problem. That one is a political one, right? Clearly.
Okay.
the top 1% of Indians, how much do we emit as compared to the average American? Okay, so top 1%, I don't know the numbers off the top of my head, but if you take the average consumption of the top, I think it was there was a Greenpeace report in which the report was in fact titled that the India's rich are hiding behind its poor. But if you look at the data in the report, it showed that even the top 2% of India's, so that's the richest in India, which includes all of us, right? Top 2% is all of us in India. That is, the top 2% emit less than the bottom 20% in the US, right? Because a lot of the emissions are structural in nature. It's not, even if my income bracket puts me in the top 1%, I still, if I need something, I've sat for dinner and don't have curd in my house, I go down to the shop and buy it and come back. Right? I don't have to take my car out and go to the next supermarket and go and get it. So some of these are just structural issues of how society is structured, planned, designed, or has grown over a period of time that has these embedded issues in it. Some of it is simply a matter of where we are in terms of level of development. But there's a huge disparity. And that is also, so if you look at, for example, there is definitely no doubt that there's high levels of inequality in India. Right? But if you take the total income in India and divide it across all Indians, every Indian will get about $2,000 per year. That will be the income. If you take the total global income and divide it across all global citizens, every Indian will get about $11,000. So that's so an average hides inequality, yes. But just this simple metric tells you that global inequalities are in fact much higher as compared to national inequalities at this point. That doesn't mean national inequalities are less or acceptable. They're not, right? But there is a huge amount of global disparity. Yeah, I get your point. I mean, the fact that they don't have more responsibility, but the potential for them to be to avoid certain kinds of lock-ins, right, is higher, and that's true. So you can perhaps pursue a different kind of urban design, right? You don't go the full vehicle road build-up, road transport route. You do look at mass transit, metros. Railways, etc., which we have not done for so long. Of course, now there is a huge increase, at least tier 1 and tier 2 cities. Metro has become a big, increasing the metro infrastructure has become a big project. But there are also limitations to this. That's true that you can do it, but there are certain kinds of things which are non-negotiable, right? For example, you shouldn't be providing, you need not have a suburban kind of urban design, right, where you have to drive for miles. I think the perfect thing is for the employers to provide housing close to employment, right? But you don't have that system anymore, where employers provide housing, unless it's a public sector company or a public sector institution. Employers don't provide housing to you, and so you have a housing market that grows very differently, and not necessarily sustainable. But can you think of urban design or urban planning exercises where you don't have these kinds of lock-ins, where it's going to be a problem? It's possible. So I agree with you that yes, those kinds of potentials are there, but you will still require housing. You will still require energy you'll still require modern amenities. You'll still require modern services. You'll need employment. You need education. You need hospitals. You need super specialty hospitals. You need all of this, and you need even public transport. And not all of this can come from renewable energy. So that's why I said that you don't need to, your target consumption need not be 180 joules and 200 joules. that of the US and Canada, right? But you can't say that you don't even need the 80 joules that you actually need to build all of these services to not just for poverty alleviation. And people in the global south have more aspirations than simply not starving. No? So, what do you need for a reasonable level of well-being for the population? That amount, at least, you must have in your projections.
Other questions? Okay, so let's thank Tejal again. Thank you, Tejal, for a very nice presentation.